Okay, so welcome to Math 158. This is section 2.1, quadratic functions and models. We're going to review quadratic functions, do some work with those. In previous section, we've talked about how to do a linear regression on the graphing calculator, and we're probably going to do some quadratic regression on the graphing calculator. So I hope you'll remember how to do those. Okay, so what we're going to do, we're going to look at quadratic function. A quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c, and again, the a is not 0. So if I write the function f of x equals 3x plus 2, notice that we got a 3 here and a 2 here. This is linear because there is no ax squared term. In fact, this term here, that x squared, ax squared term, that term is called the quadratic term. So that term is called the quadratic term. Okay. The bx is called the linear term, and the c is called the constant term. Okay, so we're going to talk about just some substitution, right? So if f of x equals x squared plus 3x plus 5, how do I evaluate f of 0? How do I evaluate f of negative 2? How do I evaluate f of 3? Okay, so really, if you think about this, right, this is true for all functions. If we have f of x is equal to x squared plus 3x plus 5, and I like to put the parentheses there for emphasis, to find f of 0, we've simply put 0 in place of the x. So 0 squared is 0, 3 times 0 is 0, plus 5 is 5. So f of 0 is equal to 5. For negative 2, okay, f of negative 2, notice that we're going to replace the x value with negative 2. So negative 2 squared is 4. 3 times negative 2 is negative 6 plus 5. So 4 plus 5 is 9, minus 6 is 3. F of negative 2 is 3. To find f of 3, f of 3 is going to equal x squared plus 3 times x plus 5, and we're going to replace the x with 3. 3 squared is 9. 3 times 3 is 9, plus 5. 9 plus 9 is 18, plus 5 is 23. So f of 3 is 23. Okay. Now, D is interesting, f of x plus h. To find f of x, remember we said that's x squared plus 3x plus 5. In this case, instead of replacing the x with 0, or instead of replacing the x with negative 2, instead of replacing the x with 3, what I'm replacing the x with this time is x plus h. So imagine you took the x out, replaced it with x plus h. Okay? At this point, I'd actually be okay if you stop right there. If you stop there and told me that this is f of x plus h, I'd actually be okay with that. But you also need to be able to expand x squared plus 2xh plus h squared plus 3x plus 3h plus 5. And notice that what we would want to do is look for any like terms. There are no like terms there. Fighting with my computer here. Okay, so there are no like terms. And so we just leave this f of x plus h is equal to this. Okay, so you can either expand it or not. It's up to you. Now, before we go on, one thing I do want to show you is a couple of options on how to handle this with the graphing calculator. Okay, so to use the graphing calculator, I have a couple of options. Okay, one option that I like to do is to say I'm going to take 0, and then see this button right here, STO. I press that when it's store. I can press store that as x. So now I press enter. 0 is stored as my x value. So notice if I do 2x, That's going to give me 2 times x is 0. 9x, 9 times 0 is 0. Okay, so what I could do is say 0 is going to equal x, and now my function is x squared plus 3x plus 5. I press enter, and there's my 5. To do b, the negative 2, I can say negative 2, store that as x, enter. I can go back up now and grab this x squared plus 3x plus 5, and when I redo this, the calculator now, instead of using 0 for x, is going to use negative 2 for x. And notice we got the 3. I can press 3, store that as x, go back up, grab that, press enter, and there's our 23. So I can do that. Okay. Another option, I go to y equals, let's clear this, make sure that those plots are all turned off. And y1, I'm going to let y1 equal x squared plus 3x plus 5. I suppose I could, one option is I could graph this thing. Of course, what's my window like, right? Let's do a zoom 6. Oops, nope, zoom 6 to get this back to negative 10 to 10 on the x and negative 10 to 10 on the y. Now you see here it says calculate. I can go second, calculate, and calculate a value. When x is 0, y is 5. If x is negative 2, y is 3. If x is 3, y is 23. Okay, so there's all those options. One limitation here is I have to graph the function. I got to be able to find the function. But what if I want to find f of 12? The calculator is going to tell me that there's a domain error because the calculator window is set from negative 10 to 10 on the x-axis. So my x values all have to be between negative 10 and 10. Okay. Another option, if I put my function into y equals, I could go to table, second table. Now the normal default, see here it says table set. The default is that both variables say auto. And so when you go to table, it starts with x is 0 and goes by ones. And I go down there and look, say when x is 0, y is 5. When x is 3, y is 23. I could go up to find negative 2. What I like to do is I like to leave my table set the way that I had it before. So I'm going to go down to my independent variable and set this to ask. Now when I go to second table, notice that this is blank. So if x is 0, y is 5. If x is negative 2, y is 3. If x is 3, y is 23. Those are all options that I like, especially if I'm going to do 3 consecutive, right? If all I need to do is find f of 3 with this particular function, nothing is going to stop me from doing 3 squared plus 3 times 3 plus 5 to get f of 3. I mean, there's 4 different options there that I can do. Okay. So number 2, same thing. Okay. The way I'm going to choose to do this is I'm going to do it algebraically. So because that's probably the least favorite, and you can back up the video and see what I did if you need to for the other options. So f of 0 is negative 2 times 0 squared plus 4 times 0 minus 1, and that's 0 plus 0 minus 1, which is negative 1. So f of 0 is negative. Okay, so f of negative 2, same thing. What we're going to choose to do is replace the x with negative 2. So we've got negative 2 times negative 2 squared plus 4 times negative 2 minus 1. So negative 2 squared is negative 2 times negative 2. So that's a positive 4. Then times that negative 2 is a negative 8. 4 times negative 2 is a negative 8 minus 1. And so we have a negative 17. F of negative 2 is a negative 17. Okay. Continuing on, F of 3, negative 2 times 3 squared plus 4 times 3 minus 1. 3 squared is 18. I'm sorry, nope. I'm thinking ahead. 3 squared is 9 times negative 2 is a negative 18. 4 times 3 is 12 minus 1. And so we have a negative 7. F of 3 is negative 7. And you can double check those with the calculator. You really want to be able to do those with your algebra. So my suggestion as you practice is to do them algebraically and then check it with the calculator. That verifies what you can do it algebraically and that you're using the calculator to verify you're doing it correctly and you're practicing with the calculator as well. And then for D, simply I'm going to say that f of x plus h is equal to negative 2 times x plus h squared plus 4 times x plus h minus 1 over good. Okay. Now, for number 3, really the only difference is my coefficients are bigger numbers. Okay, so R of 5 is negative 1600 times 5 squared plus 12,000 times 5. So I'm gonna use my calculator for both of these. So I'm gonna say 5, and I'm gonna store that as x. And we're gonna do negative 1600 times 5, times x squared plus 12,000x. And so that's going to be 20,000. So R of 5 is 20,000. So R of 10, we know is negative 1600 times 10 squared plus 12,000 times 10. But again, with the calculator, since I've got it set up, I can now store 10 as x. Go back, grab that command, and re-enter that. And that would be negative 40,000. Okay, so how to do these algebraically as well as electronically using the graphing calculator. Now the graph of a quadratic function. Okay, we're going to spend some time graphing quadratic functions. You should spend some time practicing graphing quadratic functions, and I'm going to try to do some sketching here. Okay, the graph of a quadratic is called a parabola. We're most used to seeing a parabola shaped like this. Okay, in that case, notice arrows at the end of every graph to indicate it keeps going. That's always important. This parabola is concave up. The vertex is here at the bottom, and it curves up in both directions, to the left and to the right. Okay. Some parabolas are going to be concave down. This parabola is concave down because the vertex is at the top, and it goes down in both directions from there. Okay, now remember that a quadratic is a function that can be written y equals ax squared plus bx plus c. If the a value is positive, the function is concave up. If the a value is negative, okay, if that a value is negative, then the parabola is going to be concave down. Okay, the vertex is where it changes direction. It's either the highest or the lowest point. Notice this is the vertex of the concave up parabola, and this is the vertex of the concave down parabola. The vertex is the lowest point if the parabola is concave up. The vertex is the highest point if the parabola is concave down. We often will call that point HK. The x value, we call it h, and the y value, we call it k. So you will hear me use terms HK, or use the values HK. H represents the x value of the vertex. K represents the y value of the vertex. A parabola will have exactly one y-intercept, okay? But a parabola can have 0, 1, or 2 x-intercepts. It's possible, okay, for the parabola to look like this. Notice there will be one y-intercept, but this one never crosses the x-axis. It's possible for the parabola to rest right on the x-axis, where the vertex is right on the x-axis. It can have one x-intercept. Most normally, we are used to seeing parabolas that look like this, that will have two x-intercepts, okay? So regardless, the parabola is going to have either 0, 1, or 2 x-intercepts. The parabola will always be symmetric across the axis of symmetry. So here's my vertex, right down through the middle, going through that vertex, right down through the middle, going through that vertex, right down through the middle. If that was a well-drawn parabola, we're going through the vertex is what we call the axis of symmetry. The parabola will look identical on either side of that axis, okay? The x-intercepts can be found either by factoring, if the quadratic is factorable, or by using the quadratic formula, whether the parabola is factorable or not. And we'll come back to that in a little bit. Okay. First of all, by factoring, okay, so let's spend some time here graphing the quadratic. Now, I would like to believe that all of you, let's just get the calculator out of the way, right? Y equals x squared minus 10x plus 16. We can graph the quadratic. And the calculator does a decent job of graphing the quadratic. One thing that I don't like about the graphing calculator is it doesn't label points, and you're going to be expected to label points. So let's talk about how do we find those points. First of all, this quadratic is factorable. Okay. What are the factors of 16 that add up to negative 10? If I take the factors of 16 and I look for the factors of 16 that add up to negative 10, they are negative 2. Yeah, I'll be okay. They are negative 2 and negative 8. Because negative 2 times negative 8 is a positive 16, but negative 2 plus negative 8 is a negative 10. Okay, so this will factor as x minus 2. Let's write the whole thing. This will factor as x minus 2 times x minus 8. Now, if I were to set this equal to 0, let me give myself some room over here. If f of x equals x minus 2 times x minus 8, and I set this equal to 0, then either x minus 2 will equal 0 or x minus 8 will equal 0. So then x will either equal 2 or x will equal 8. And so those are my x-intercepts. If you look back over here at the graphing calculator, you can see the point 20 and the point 80. The quadratic has x-intercepts at 2 and 8. So if I'm going to try to graph this quadratic, at 20 and at 80, there are x-intercepts. Okay. Then I want to find the axis of symmetry. Here's what I think is the best way to handle this, quite honestly. The axis of symmetry is going to go right down through the middle. So I want to find halfway between 2 and 8. 2 plus 8 divided by 2 is going to be 10 divided by 2, or 5. Right down through the middle is the line x equals 5. That is my axis of symmetry. My vertex is going to be on that point. So that HK, right? H is 5. because 5 is halfway between 2 and 8. If I take the 5 and plug it back in here for if I plug it back in here for x and I find f of 5, k will equal f of 5. This is how I found h. To find k, I do f of h. So I'm going to do f of 5. Now, I could put the 5 in for x squared minus 10x, which is fine. That's where most people will choose to put it in. Or f of 5, I can substitute it in the factored form. I actually prefer to put it in the factored form because 5 minus 2 and 5 minus 8 is a lot easier to handle. So this is negative 9. And here is my parabola. That's a pretty ugly picture. That's my parabola. I also should find my y-intercept here. That y-intercept is 0, 16, because the y-intercept, x will equal 0. So I'm going to find f of 0, which is 16. And there's my parabola graphed. Okay, if I want to find those things on the graphing calculator after I graphed it, I could go to second calc. And number 2, I can ask it to find a 0, but notice it's going to say left bound, so I need to make sure that my cursor, where is my cursor? See that? I'm somewhere to the left of the 2, which I am. I'm going to press enter, and now I need to move my cursor to the right of that 0, which it is. So notice now I have a lighter line to the left and to the right, and now I'm going to guess. My guess doesn't have to be good. I just need to have my cursor between the left and the right bound, and I have a 0, 2, 2, 0. That I think is more work than the factoring. I prefer to factor. To find the other 0, select number 2. And I need to be somewhere to the left of this 0, and now it's asking for the right bound, so I need to be to the right of that 0. Go back somewhere in between, and here's my 0, 8, 0. So that gives me the other root, or the other 0. To find that vertex, what I'm going to calculate is number 3, the minimum value. It's the same thing. I need a left bound and a right bound. So my cursor needs to be to the left of that minimum, enter. And then now I got to set a bound to the right, press enter, and somewhere in between, and I get 5, negative now. Now, one of the things you've got to understand about the calculator is that there's this process that it uses. In our algebra, quite honestly, is better than the process the calculator uses. So just because of the estimating processes the calculator is using, it doesn't always get it exactly right. This x value is not 5.00000013. That x value is 5. Okay, so you've got to be careful with that. And sometimes it might actually take more knowledge and understanding of the graphing calculator to graph the quadratics than just to do it algebraically. Okay, so let's move on to number 5. Are there any factors of negative 15 that add up to a positive 2? Yes. Positive 5 and negative 3. So x plus 5, x minus 3. So if I set x plus 5 equal to 0 and x minus 3 equal to 0, I get negative 5 and 3. So that tells me that my quadratic is going to have an x-intercept at negative 5 and an x-intercept at 3. Now I want to find halfway between those. Halfway, okay, to find h, I'm going to find halfway between -5 and 3 by adding them together and dividing by 2. And so -1 is halfway between -5 and 3. So x equals -1 is my axis of symmetry. To find k, I'm going to find f of h, which is f of -1. And so that's going to be -1 squared plus 2 times -1 minus 15, which is -16. So my vertex, and I don't need to go 1, 2, 3, 4. I can kind of estimate here is the point -1, -16. And there's my parabola. Notice I am emphatic. You need to have the arrow on each end. Okay. And my y-intercept here is 0, -15. And I got that by doing f of 0. 0 squared plus 2 times 0 minus 15. Okay. And so that one's graphed. Number 16. Again, I'm going to factor this. I'm going to try to factor it. Are there factors of 4 that add to 4? Yes, there are 2 and 2. Now, this one's going to be interesting because this is going to factor as x plus 2 times x plus 2. So if I set those each equal to 0, I get -2 twice. This tells me that I don't have 2 x-intercepts. I have 1 x-intercept at -2. Okay. Now I can try to find halfway between -2 and -2, but it's going to be -2. That tells me that that axis of symmetry goes right down through this point, x equals -2. And so that's the vertex of my parabola. My y-intercept here is 0, 4. And so really those are the only 2 points I get right there. I could find a third one, and I could have done this in the other 2 as well. This distance here is 2. Therefore, this distance here is 2. If I start at the 0 and I go 4 units to the left, I can find that point, -4, 4. Okay, and so there's that point on the quadratic. Now, something I do want to show you. Remember, the quadratic is a function in the form ax squared plus bx plus c. I'm not going to take the time in this video to develop this, but remember our vertex is the point hk, and I've been finding k by doing f of h. Back the video up and look for that here, okay? I did that here, did that over here. We can also find h by doing -b over 2a. Here's my b and here's my a. Remember this 5? We got 5 by finding halfway between 2 and 8. Well, the other thing I could have done is b is 10. So I could have done the opposite of -10 divided by 2 times the a value, which is 1. And that would have been 10 divided by 2, or 5. We could have found that h value by getting 5. Here, we found our x-intercept at -5 and 3, -5 and 3. And then we said h is -5 plus 3 divided by 2. So our h was -1. The other way I could have gotten h there is I could have done the opposite of b over 2 times my a value, which is 1. And that's -2 over 2, which is -1. I could have gotten that h value either way. Same thing in number 6. I'm not going to take the time to do it right now, but I could have done the same thing in number 6. The reason I mentioned that here in number 7 is for number 7, if I look for the factors of -5 that will add up to 2, those are the only numbers, those are the only two integers I can multiply together to get 5. There are no factors of the -5 that will add up to 2. So I'm going to have trouble finding my x-intercepts. So what I might choose to do is, rather than finding my x-intercepts first, I might choose to find my vertex. To find my vertex, I need to find my h value. Now, I can't find my h value by adding the x-intercepts and dividing by 2 because I don't have my x-intercepts. So I'm going to find my h value by doing -b over 2a. b is 2, a is 1. b is 2 and a is 1. So that's -b over 2a. -2 over 2 is -1. So my axis of symmetry is -1. To find k, I'm going to do f of -1, which is -1 squared plus 2 times -1 minus 5. That's 1 minus 2 minus 5 is -6. So right about there, -1, -6 is my vertex. And my parabola is concave up. Much better writing on a whiteboard on the wall than on the computer. Okay, so now I could, I suppose, decide I need to find my x-intercepts. And if I need to find my x-intercepts, I would suggest that you use the quadratic formula. But really, in numbers 4, 5, and 6, we find the x-intercepts because they're relatively easy to find. They're relatively simple to find. If all I need to do is graph the quadratic, there are times where I need the x-intercepts, okay? There are times I need the x-intercepts, but there are times I don't. And in this case, all I need to do is graph the parabola. Well, what I might suggest that you do is say, well, if x is 0, this is -5. Now you'll find again that this distance here is 1, so this distance is 1, so this point here is going to have an x value of -2 and the same y value of -5, because these 2 points here and here are directly across horizontally from each other on the parabola. So I can get 3 points. Okay. Number 8, we'll do this one as well for completeness. This one does factor. The factors of 3 that add up to 2. Oh, does it factor? 1 and 3, -1 and -3. No, actually, that does not factor. So I'm in the same boat. I'm going to find my h value by doing the opposite of b over 2a. That's -2 over 2, which is again -1. A lot of these parabolas, they just happen to have an axis of symmetry of x equals -1. Now to find k, we're going to do f of -1, which is -1 squared plus 2 times -1 plus 3. That's 1 minus 2 plus 3. Notice that that's +2. So my vertex here is the point -1, 2. And a is positive, so my parabola is concave up. 0, 3 is my y-intercept. That should be fairly simple to find because that's f of 0, which is 0 squared plus 2 times 0 plus 3, which is 3. Directly across, that's a distance of 1 and another distance of 1. So -2, 3 should be another point, and here's my parabola graphed. And you'll notice number 8 is an example where the parabola has no x-intercepts. Numbers 4, 5, and 7 are all examples where the parabola has 2 x-intercepts, and number 6 is an example where the parabola has 1 intercept. Okay. So what else are we going to talk about? So here's some applications, okay? And I like these, wink, wink. Okay. Recall that revenue, we've talked about revenue before, is the total payment received for goods sold. We use Q to represent the quantity of items, the quantity of units sold, and P to represent the price of those units sold. So my revenue is equal to price times quantity. Again, if I were to sell 100 t-shirts, Q would be 100. And if I sell them for $12 each, my P would be 12. My revenue then would be $12 per t-shirt for each one of the 100 t-shirts, or $1,200. Okay. I'm thinking about starting to make furniture to sell. I'm thinking about making bookshelves and selling bookshelves at $250 each. So I'm hoping with my first set of bookshelves that I will be able to make 4. So Q would be 4. And my price of 250, my revenue would be my price 250 times my quantity 4. My revenue would be $1,000. Now be careful, that's my revenue. That's not my profit, that's my revenue. My estimate is that it will cost me, materials will cost me $50 per bookshelf. So my cost will be a total of 4 times 50, or $200. So my profit will be my revenue minus my cost. Which is 1,000 minus 200. So my profit would only be $800 if my revenue is 1,000. Okay. So let's look at Dawn here. Dawn Sweater Shop. She estimates the demand function for new fall sweater to be negative 1,500p plus 60,000. Okay, that's Q. And she expects them to sell for P dollars each. Okay. Now, notice I have a slope here of negative 1,500, which means that Dawn would expect that for each $1 increase in the price of the sweaters, that she would expect to see a decrease of 1,500 sweaters sold. Okay. So what should Dawn charge? If this is her demand function, she has figured that out. She's done some research to estimate the demand function there. She wants to maximize her revenue. Well, remember that the revenue is going to equal price times quantity, or quantity times price. It doesn't matter which order you do those. I think up here I said price times quantity. It doesn't really matter because multiplication is commutative. I can multiply in either way. So for Dawn, her price is P dollars each, and her quantity is negative 1,500p times 60,000. So my revenue is negative 1,500p squared plus 60,000p. Okay. Now, here's a suggestion I'm going to make that you look at this again and again. She wants to maximize the revenue. So first of all, notice that the A value here, A, is negative 1,500, B is 60,000. Remember, since A is negative, this parabola is concave down. The parabola is going to be concave down. Her maximum profit, her maximum revenue, we're talking about revenue, is going to occur at the vertex. Remember, the vertex is HK. So if I want to know, this is P and this is revenue, here's price and revenue. If the question is, what should she charge per sweater to maximize her revenue? The question is, what's the price? What's H? And remember that H, sorry about that. Remember that H is negative B over 2A. So her H is going to be negative 60,000 divided by 2 times negative 1,500. So that's negative 60,000 divided by negative 3,000, which is 20, right? Let's check that out. Negative 60,000 divided by negative 3,000 is 20. So $20. What should Dawn charge to obtain the maximum revenue? $20 to maximize revenue. So in order to maximize her revenue, she should sell the sweaters at $20 each. Now, if I wanted to know, the question doesn't ask this, but if I want to know what would the maximum revenue be, that would be the revenue at $20. So that would be negative 1,500 times 20 squared plus 60,000 times 20. So negative 1,500 times 20 squared plus 60,000 times 20. So that would be a maximum revenue of $600,000. Again, remember that's revenue, not profit. To find the profit, she would have to subtract her cost from her revenue. Here's another example. As the operator of Z Sport Fitness Gym, you calculate your demand function to be, this is going to be similar, might be the exact same thing, we'll see. The demand function is Q equals negative 0.06p plus 84, where Q is the number of members in the club and P is the annual membership fee that you're going to charge. Your annual operating costs are a fixed cost of $20,000 per year plus a variable cost of $20 per member. Find the annual revenue and profit. Okay, so get ready for some work. Let's talk about revenue. Okay, revenue, like we've said before, is P times Q. P is the annual membership. The demand is negative 0.06p plus 84. Because notice, as the P increases, the amount of memberships will decrease. You raise your price, fewer people want to buy your product. That's how it works. Okay, so my revenue is negative 0.06p squared plus 84. So that's revenue. Profit. Remember that profit is revenue minus cost. So before I can find my profit, which is going to be revenue, negative 0.06p squared plus 84. Okay, substitute that in. I need to find cost. Okay, now cost, there's a fixed cost and there's a variable cost. The fixed cost is $20,000. Now, I told you a few minutes ago, I've thought about making and selling furniture. And I mentioned if I make a bookshelf, my cost would be, let me go over to the side here. If I were to make bookshelves, which I'm thinking about doing, okay, that says bookshelves. My cost, I have a fixed cost and I have a variable cost, okay? And I mentioned that it was going to cost me $50 in materials for each bookshelf that I make. That's a variable cost. If I make one bookshelf, it's going to cost me $50. If I make two bookshelves, the cost is $100. If I make 3 bookshelves, it's $150. That cost is going to vary depending on how much it costs me, how many bookshelves I make. Okay. And we talked before about marginal versus variable. Okay. So the marginal cost is $50. So my variable cost is 50x. It's going to cost me $50 for each bookshelf I make. What's my fixed cost? Well, in my shop, I have a table saw. I have a drill, driver, drill press, miter saw, hammer, all the materials that I have. Heat, what if it's cold out and I need to heat my workshop? Okay, the cost of heating, the cost of having all of those tools doesn't change based on how many bookshelves I make. That would be my fixed cost. So the fixed cost is the cost of being able to make things. Okay, my wife likes to say, oh, it'd be really nice if I had this. I recently made a hutch. It'd be really nice. What does it cost to make a hutch? It cost me $500 in materials. What about tools? Well, that's still my fixed cost. Okay, so notice here that your annual operating costs are a fixed cost of $20,000 per year. That's your cost of being able to run your gym. Then you have variable costs, which is $20 per member. So for the gym, it might be that you're going to pay your rent, but your variable cost is you got to do more laundry, towels and things, depending on how many members use your facility or how much they spend in water for showers afterwards or whatever. So your cost is a fixed cost of $20,000 plus $20 per member. And remember that Q is the number of members. So this is your cost. So I'm going to substitute my revenue for R. I'm going to substitute my cost for C. And I'm probably going to run off my page here. Now Q, though, remember, Q is negative 0.06p plus 84. So I've got negative 0.06p squared plus 84 minus 20,000. But now here, I'm going to distribute, let's go to a different color. I'm going to distribute 20 times negative 0.06. So that's negative 1.2p. And 20 times 84. 20 times 84 is 1680. Okay. But now be careful because we're subtracting this. So it's minus a negative 1.2p and minus a positive 1680. Okay. So we've got negative 0.06p squared plus 1.2p minus, well, we got plus 84 minus 20,000. Well, you know what? I'm staring at this. This is a P here. I forgot way back here to distribute that P. So let's save that right there. That's a P. Now I feel better. I apologize. So we've got 84p and 1.2p. So that should be an 85.2p. Then minus 20,000 and minus 1680 is minus 20,000. So that's my profit. Okay, so there's a lot there. One of the benefits of the video is that you can slow it down, back it up, repeat it if need be. At what price should you set the annual membership fee to obtain the maximum revenue? Okay, that's maximum revenue. So let's do that in blue. So the revenue is negative 0.06 p squared plus 84p. So our A value is negative 0.06. Our B value is 84. So H is going to be sorry about that. So our H is going to be negative 84 over 2A. So that's going to be negative 84 divided by, put this in parentheses, 2 times negative 0.06. That would be 700. So at what price should you set the annual membership to obtain the maximum revenue? $700 a year. What is the maximum revenue? Well, I'm going to store that as X, and it's going to be negative 0.06x squared plus 84x. And where I'm getting that from is this is my revenue function. I'm putting that 700 back in for the P. And so my maximum revenue is 29,400. So that's the price that will maximize my revenue, and that is my maximum revenue. Now, at what price did you set the annual membership to obtain the maximum profit? And what is the maximum possible profit? And the corresponding revenue. So let's do that. So my profit, remember, from up here, profit is negative 0.06p squared plus 85.2p minus 21,680. So if I want to maximize my profit, again, A is negative 0.06, B is 85.2. I want to maximize my profit. That's the H value of the vertex, which is negative B divided by 2A. So it's very similar to what we did before, except it's negative 85.2 in the numerator divided by 2 times negative 0.06. And so my price would need to be 710. So that price of 710 will not maximize my revenue, right? 700 will maximize my revenue, but 710 is going to maximize my profit. What is the maximum profit? Well, this is profit. So we're going to do maximum profit is negative 0.06 times 710 squared plus 85.2 times 710 minus 21,680. So that's going to be negative. What I'm going to do is I'm going to store that answer as X. So I can do negative 0.06x squared plus 85.2x minus 21,680. My maximum profit is 85.66. Okay. And then the question here is, what would be the corresponding revenue? Well, my revenue at a price of 710 is going to be less than 29,400. I know it's going to be less than 29,400 because 29,400 is my maximum revenue with a price of 700. I'm looking at a price of 710 now, my maximum revenue, so I'm going to use this function again. Now my X value is still 710, right? So my revenue was negative 0.06x squared plus 84x, or negative 0.06p squared plus 84p. But now that x is 710, that maximum revenue is 29,394, $6 less. Okay, so there's some fun with the quadratics. There's an application of quadratics. Okay. Last thing I want to look at is what if we have a table of values. We did this before with linear regression. The following table shows some annual revenues in billions of dollars earned by Amazon from 2004 through 2014. Is a linear model best for this data? Well, first of all, let's check it out. Okay, we've got a 2-year span, a 2-year span, a 2-year span, a 2-year span, and a 2-year span. If a linear model is best, then the increase would be the same. And it doesn't look to me like the annual increase is the same. So the linear model is not best for this data. No, because the annual increase is not constant. Okay. Now find the quadratic model for the data. If you recall, and I'm going to use the calculator. I'm going to encourage you to use the calculator. Okay. So we had gone to stat, calc, number 4, linear regression, to find the linear regression. To find quadratic regression, I'm simply going to go to number 5. Okay, but notice that my X values, my Y values need to be in a list. So I'm going to come back to here. First, I'm going to quit, stat, edit. What I need to do is put my years in L1 and my revenues in L2. Okay, so my calculator is still from when we did this with linear. So my Y values are 7, 11, 19, 34, 61, and 89. So notice those are my Y values. My X values need to be the years, and it looks like those are still the years, where X does not represent the year 2004 or 2006, but X represents the number of years since 2000. So I'm going to write that down. X equals the number of years since 2000. So stat, calc, number 5, quadratic regression. My X values are in L1. My Y values are in L2. I don't need my frequency list. I am going to do that store reg EQ. We've done that before. Alpha F4. And I'm going to select number 1. So the regression model for this data is Y equals 0.875x squared minus 7.536x plus 23.571. Now I went 3 decimal places with the A, so I went 3 decimal places with the B and C as well. Determine which model is better for the data. Okay, I believe we talked before about the R value. The R is 0.998, which is closer to 1 than it would be for the linear. Okay, but also we've talked about this before as well. Second stat plot. I'm going to turn my plot on. We did the scatter plot before, and then we hit a zoom 9 for the zoom stat. So see how the data is curved? Because the data is curved, the quadratic is better. So the quadratic model is better than the linear model. Now, I'm not saying the quadratic model is best. I'm saying the quadratic is better than the linear because the data is curved and the quadratic is curved. And notice we almost hit every data point. So the last thing here is if I want to use the quadratic regression to predict Amazon's revenue in 2020, instead of calling this Y, I'm going to call this R for revenue. I would need to find R of 20. 0.875 times 20 squared minus 7.536 times 20 plus 23.571. And you can do that on your home screen, but remember, I also showed you can go to second calc and select number 1 to find the value when X is 20, because X is 20 years after the year 2000. But again, our calculator is screaming at us because we're wanting to go up to 20. If we hit a window, we can see that our X max here is 15. So we're going to set our X max to say 25. So notice the graph is scooped over here farther to the left. Second, calculate the value when X is 20. And we would use this model to predict it in 2020. Amazon's revenue would be 222.9, wait for it, billion. We would expect that in 2020, Amazon's revenue was $222.9 billion. Okay, so there's quadratic functions, quadratic regression. Algebraic, using the graphing calculator, I'm okay if you use both. You should actually do both together in tandem. Okay.